Bismillah and Assalamualaikum. Today we are going to present about polymer processing instrument, specifically thermoforming.
This is our group members that work together to complete the assignment.
This is a brief overview of our presentation on the topic.
Hi everyone, today I'm going to talk about the thermoforming machine, which is a really important tool in polymer processing. Let's begin with the process itself. What is thermoforming? Thermoforming is when we take the plastic sheet, heat it until it is soft and flexible, and then shape it over a mold. Once it takes the shape of that mold, it is cooled and trimmed into a usable product. It is a simple idea but very powerful and widely used in industries all around us. Now, what is a thermoforming machine? Basically, it's the machine that does all of this. It heats the plastic sheet, forms it using a mold, and either vacuum or pressure, and then cools it down into the final shape. You will find these products made by these machines everywhere. Things like food packaging trays, clear plastic containers, disposable cups, and even car interior panels. There are different types of thermoforming machines, and each works a little differently. The first one is vacuum forming. This uses suction to pull the soft plastic sheet tightly over the mold. Next is pressure forming, where both vacuum and compressed air are used. This gives more detailed and sharper edges. And lastly, there's mechanical forming, where the mold physically presses into the plastic to create the shape.
Thermoforming is based on a simple but important property of certain plastics called thermoplastic. These plastics become soft and flexible when heated, but they don't completely melt. This means we can heat a flat plastic sheet until it's soft enough to be shaped. Once the plastic is soft, we can shape it into a new form using molds. After shaping, we cool the plastic so it becomes hard again and keeps the shape we gave it. This cooling process is important because it makes the new shape permanent and strong. One of the great things about thermoforming is that this plastic can be reheated and reshaped many times without losing their qualities. This makes thermoforming a very efficient and cost-effective way to make plastic parts. That's why this process is used a lot in industries like packaging, automotive, and many others where lightweight and detailed plastic products are needed. Thermoforming is a manufacturing process that turns flat plastic sheets into useful 3D shapes by using heat and a mold. The process starts by clamping the plastic sheet in a frame to hold it in place. Then, the sheet is heated until it becomes soft and flexible. Once it reaches the right temperature, it is formed into a specific shape using a mold. There are a few ways to form the shape. First, vacuum forming pulls the sheet onto the mold using suction. Second, pressure forming uses air pressure to push the sheet onto the mold. And last, mechanical forming uses a plug to help shape deeper parts. After the forming step, the plastic is left to cool so it can harden and keep its new shape. Next, any extra material around the edges is trimmed off, and the part may go through finishing step like drilling. This process is fast, cost-effective, and commonly used in industries like packaging, automotive, and electronics.
Now, I will be presenting the key components of a thermoforming machine. The key components that enable this machine to transform plastic sheets into molded products can be summarized into 5 main parts. They are heating element, clamping unit, forming station, vacuum or pressure system, and also a cooling and trimming system. So, let's get into the functions of each one. First, we have the heating element. This crucial part heats the plastic sheet until it becomes soft and pliable, making it ready for shaping. The heating element controls temperature to ensure steady heating. Next is the clamping unit. Its job is to hold the plastic sheet firmly in place during the heating and forming process. This prevents any shifting or wrinkling that could ruin the final product. Third, we move on to the forming station. Here, the heated sheet is shaped by applying vacuum, pressure, or mechanical force depending on the method used. This is where the shape forms. Fourth is the vacuum or pressure system. It functions to pull or pushes the heated plastic tightly onto or into the mold. It is to ensure fine detail and accuracy in the final shape by creating suction or applying air pressure. Lastly, we have the cooling and trimming system. Once the plastic is formed, it needs to cool down to hold its new shape. Then, excess material is trimmed away to create a clean and finished product.
Next, we will look at types of polymer typically processed using thermoforming. This method is mainly used with thermoplastic, which are plastic that can be reheated and reshaped multiple times. Polystyrene, or PS, is one of the easiest to thermoform. It's lightweight and inexpensive, making it popular for products like disposable cups, food trays, and packaging inserts. Then, polypropylene, or PP, is more challenging to form, but it still used in applications like automotive parts and microwavable container because of its heat resistance. Polyethylene, including both LDPE and HDPE, is widely used. LDPE is flexible, while HDPE is tough. You will find them in lids, bottles, and trays. Polyvinyl chloride, PVC, is known for its clarity and chemical resistance. It's commonly used in blister packs and clamshell packaging, especially for consumer goods. Next, polymethyl methacrylate, PMMA or acrylic, is valued for its excellent optical clarity. It's used in display panel. Last but not least, acrylonitrile butadiene styrene or ABS is strong and impact resistant. It's used for things like car dashboard, tool housing, and luggage shelves. Basically, it's for automotive parts.
Now, I will explain how thermoforming is applied across several major industries. This process is popular due to its efficiency, scalability, and ability to produce complex shape from plastic sheets. Let's begin with the packaging industry. Thermoforming plays a crucial role here because it offers lightweight, durable, and affordable solution. One of the most common products is clamshell packaging, which we often use it for electronics, batteries, and hardware tools. This provides both visibility and protection for the product. Then, we have blister packs, especially common in the pharmaceutical industry, where individual pills are sealed in clear pockets. Thermoform food containers and trays are also widely used to package items like fruits, meats, and ready-to-eat meals. Next, let's move on to the medical industry. In healthcare, thermoforming is essential for creating sterile and precise components. For example, medical trays. Medical trays are used to safely organize surgical instruments or disposable medical kits. Thermoforming is also used to make equipment enclosure, which are the plastic covers for diagnostic and monitoring machine. In addition, custom orthotics and support devices, like braces, can be thermoformed to match a patient-specific shape, providing better comfort and support. Moving on to the automotive sector, thermoforming helps manufacture both interior and exterior car components. Parts like door panels, dashboards, and trims are formed using this technique due to its design flexibility. It's also used to make underhood components, such as protective covers for engine parts. And don't forget cargo liners and trunk trays, which are durable inserts used for organizing and protecting storage area in the vehicles. To sum up, thermoforming is an incredibly versatile process used across packaging, medical, and automotive industry. It supports high volume production, reduces costs, and delivers reliable, customized parts.
Let's begin with the advantages. First, thermoforming is cost-effective, especially for small to medium production runs. The tooling and mold costs are significantly lower than in processes like injection molding. It also has a faster setup time and shorter production cycle, making it ideal for prototype and quick turnaround project. Another strength is it is versatility. Thermoforming can produce both small and large parts in various shapes, and it supports a wide range of thermoplastics such as ABS, PET, and PVC. This method is also known for producing lightweight, rigid parts with a good surface finish, particularly when using pressure forming. Lastly, modifying tooling is easier and more affordable, which make design change quicker and less costly. Now, let's look at some limitations. Thermoforming is limited to thermoplastic sheet, meaning it can be used with thermoset or non-sheet form. Another drawback is lower dimensional accuracy, which means lack of detail and complexity, making it less suitable for parts that require tight tolerance or fine detail. The process can also lead to uneven wall thickness, which may affect product strength. Additionally, thermoforming is not ideal for very complex shapes or multi-cavity mold, and the structural strength of parts is generally lower compared to other methods. Finally, thermoforming is not efficient for very high volume production.
The fully automatic thick sheet thermoforming machine processes materials with a thickness range of 2 to 14 millimeters and is ideal for manufacturing car floor mats. The process begins with automatic material feeding, followed by the lowering of the pressing frame. The material is then advanced into the heating furnace, where it undergoes heating. Once the material is fully heated, the furnace retreats, and the vacuum thermoforming process begins. After thermoforming, the material cools and solidifies in the cooling area. Once cooling is complete, the pressing frame rises, and the product moves into the cutting area. Finally, a robotic arm grabs each individual product and removes it from the machine.
Sadhana Izati. So throughout the presentation, we have discussed the theory behind how thermoformings work, from heating the plastic sheet to forming it into specific shapes and trimming the final product. Now in this video, you will see that theory in action. This footage is provided by Shanghai Zanzi Mechanical Equipment Co. Limited, a professional and experienced thermoforming machine manufacturer based in China. Watch as the machine carefully heat the plastic material, shape it using precision molds, and trim the finished pieces, all through a seamless automated production process. It's a great demonstration on how the concept we have covered are applied in a real industrial environment. Thank you.